Divergent D equal to rho V. Divergent B equal to 0. Divergent D equal to rho V. Divergent B equal to 0. Hey, why so many equations for this chapter? How can I memorize all of it? I think YouTube can help me to memorize this equation. Let me search.
Divergence of D equal to rho V. Divergence B equals 0. Curl of E equal negative del B over del T. Curl here equal to J plus del D over del T. That is formula Maxwell equation that you have to remember all the time, all the time, all the time.
Oh, that's so easy to memorize the equation. Now let's me rewrite it again. Divergence D equals rho V. Now I'm done. I want to go to it.
Okay.
Hey, nasi.
Hey Ale!
Do you
Why?
cool cut?
Of course, my cat not
You
you.
want to know about this? Fun fact about this.
What?
This related to our lesson.
What lesson?
Maxwell equation.
Maxwell equation. Which one?
Faraday law, mate.
Are you serious?
Yes, mate.
How you know?
Actually,
Ah.
I'm educated.
What is it?
Nasi.
So let's recap 4 Maxwell equation. The first one is Gauss law, where D is electric flux density and rho V is equal to volume charge density. Second one is Gauss law for magnetic, where B is magnetic flux density. The third one is Faraday's law, where E is induced electric field and del B over del T is the rate of change of magnetic flux density. The last one is Ampere's law, where H is magnetic field intensity, J is electric current density, and del D over del T is the rate of change of electric flux density.
One of the applications for the third Maxwell equation is magnetic card reader. Let me share with all of you on how does the card reader works. As we can see on the back of the card, there is a magnetic stripe which contains a layer of ferromagnetic material, typically iron oxide, embedded with a plastic substrate with information stored in it. This material helps it to retain its magnetic properties even after an external magnetic field is removed. The stripe acts as a bar magnet. It is made up of very small magnetic particles, with each one acting a bar magnet. When the card is made, these magnets are arranged in a specific order to store information like the account number and expiration date. So when placed in a very strong magnetic field, the polarity of the particle is flipped and information is encoded.
When the card is moved or swiped through the reader, the change in magnetic flux is produced in one direction, whether north or south pole. The magnetic head within the reader detects the changes in magnetic field and the transitions between north and south poles of magnetic flux generates an electrical signal.
This is described by Faraday's law, which is the third Maxwell's equation. So, this is the derivation of Faraday's law. Now, it looks rather simple. What does this law describe? This law describes that in a given amount of time, the change in magnetic field will produce voltage.
The current received by the pickup coil goes through the signal amplification and is translated into binary code, which is done by alternating magnetic fields so that the signal can be used by the connected system such as payment terminal or access control system. The transitions between the magnetic fields commonly represent binary zeros and ones.
Okay, fun fact. So, did you guys know if you swipe the card too slow, there is no quick enough change in the magnetic field so that no current will induce the card reader. But we also cannot swipe the card too fast because the change in magnetic flux is too rapid to be discerned by the card reader. Thus, it cannot be detected. As a conclusion, we should acknowledge the significance of these four Maxwell equations, as they serve as the foundation for technology's advancements, particularly in the development of devices like generators and motors.
Orang lain tadi.